All right, Unit 5 deals with exponential functions. So this is our last unit before we call it a term. All right, and so one of the things to notice about Unit 5 is that our exponents are going to be variables. So that's something new that we haven't experienced yet, where our exponents are variables. Okay, so we have this function of an equation, this y equals a times b to the x. That's going to be really important for us as we go through these. The b value is whatever is raised to the exponent. The a value is the y-intercept. That means where this graph is crossing the y-axis. That's the a value. The b value is going to tell us the shape of our graph. Our b value is always going to be a positive number, so you can see that over there. B is going to be greater than 0. That means it's going to be positive. Why do you think b cannot be equal to 1? Any ideas why b cannot be equal to 1?
B is greater than 1.
Okay, but 1 is greater than 0.
B cannot equal 1. That's 1.
Right, but my question is why?
1 times the number is itself.
1 times the number is itself. Right? If you do 1 to the 3rd power, you're still getting 1. If you do 1 to the 107th power, you're still getting 1. Right? So it doesn't help us change the graph. So b is never going to be 1. But if you look at example 1 here, it says, sketch the graph of y equals 2 to the x. Is there an a value here? Do we see an a value? Okay, when we don't see an a value, what number could we put there that's not going to change the problem?
1.
Excellent. We are going to put a 1 there. So we know that our a, we could really write this as y equals 1 times 2 to the x. That's the same thing. Remember that a value is going to tell us what the y-intercept is. So if we don't see it there, we know that the y-intercept is really 0, 1. Right, because it's this number right here, and if it's crossing the y-axis, the x value is 0. We're going to use a table of values to tell us kind of what this graph should look like. So what I'd like you to do over here to the left is create an x and a y table, and then we're going to use our calculator to help us. Okay, so grab your calculator. Go to your y equals, clear that out. You do not need to put the 1 in there, okay? You don't need to put the 1 in there. You're just going to do 2 raised to, so your little caret button, the x power. And then we're going to hit graph. And this is what our graph should look like, a curve like this. Okay, so go back to your y equals. Do you have 2 raised to the x power? And then did you arrow over to get off of your exponent mode? All right. So then, if we want a table of values, I can go second table, which is my graph button, second graph button. And I can move up and down. So we can see when x is -2, we're at 0.25. That 0.25 is going to be a little bit hard to graph. Would you guys agree that that's a quarter? That's going to be hard to graph. So when we have our x and y axis, oh man. So when we have our x and y axis, or our table of values, let's go ahead and pick some of the points that we know we could graph. We could probably graph -1 and 1/2. 0, 1, that was my y-axis. Your what? If you cannot see the values that I have on my calculator, that means you need to arrow up and down to get to those values. Okay? So I could also plot, can we plot 1, 2? We could probably plot 1, 2, right? On an x and y axis. What's another one we could plot? 2, 4. And we could do 3, 8 if we wanted to. Right, it's going to be super big if I do 4 and 16, okay? So over on the other side, notice that are any of our y values 0? Are any of our y values 0? No. So I don't even need to go into the negative y's. I'm going to draw my x-axis pretty high. I'm sorry, pretty low. So then I'm going to plot these points. If I have negative 1 and then about 1/2, it's here. We're just plotting points. Then I'm going to plot the point 0, 1. I will give you graph paper for your homework. Then I have the point 1, 2. Two, 4. Three, 8. And then I'm going to connect my curve. This is a curve. And it has arrows on the ends. Notice that it is not increasing at a solid rate, right? It's not like going up by 2. If we think about a linear equation, or if we had a line, it goes up steadily. Do you guys agree with that? It goes up steadily. This one takes off and then it goes really fast. That would be what happens with every exponential curve. Now, if the graph is going up like this, we would call this exponential growth. Exponential growth. So what is the b value here on this problem? What was our b value? 2. So the rule is, if your b value, listen carefully, if your b value is greater than 1, the graph is going to be exponential growth. If the b value is less than 1, it's going to be what we call decay, exponential decay, meaning decreasing. Okay, so that's really important that you know this. If it's greater than 1, it's growth. If it's less than 1, it's decay. And usually our graphs will look like such. So a growth graph will typically look like this. A decay graph will typically look like this. But not always. Okay? So when our y-intercept is negative, it's going to look a little bit different, and I'll show you an example of that in just a second. All right, let's look at these examples down here below. Okay, so right there it talks about exponential growth. It's happening when something's increasing. I already told you b is greater than 1. If it's decay, then that means the b is going to be less than 1. If it's less than 1, that's a fraction, right? So if you want to make yourself a note that this means that there is going to be a fraction. So when your b value is a fraction, that's going to be decay. All right, so examples A, B, and C says determine whether each function represents growth or decay. But not only growth or decay, but I want us to create a table of values, and I changed that on your notes, didn't I? I just didn't change it on mine.
No, it says that.
Yeah, but it says in create a table of values. So I changed that on yours, but not on mine. Okay, so the first thing on letter A is for us to identify whether this is growth or decay. What would you guys say about letter A? Is it growth or decay? Decay. Why do we know it's decay? Good, it's a fraction. Okay, so we're going to write off to the side that this is decay. And then what is the y-intercept? 1, right? Because there's a hidden 1 in front. So 0, 1 is my y-intercept. Now we're going to create a table of values. So get your calculator out. And we're going to go to y equals. Does anyone know how to put in 1/5 to the x power?
1 divided by 5.
Okay, but if you do 1 divided by 5 and then raise it to an x, that means that it's only going to raise the 5 to the x. So we need to put in parentheses 1 divided by 5, close your parenthesis, raised to the x power. Okay? Then if you have exponent mode on your calculator, just arrow over. Then we can look at kind of what our graph should look like. It should be going down. Excellent, it is going down. So now let's go to our second table. Now if you look at these table of values, my calculator automatically populates onto x is -2. So arrow up and down until you get to where I am, where x is -2. Arrow up and down until you get to see x is -2 on your calculator. It's going to be almost impossible to do -2, 25, right? Like 25 is way going to be off of our graph. So instead, let's start maybe at -1. Okay, so if I'm going to start at -1, and mine went off the board. So I had -1, 5. So I'm just pulling values off of my table. And then it was 0, 1. What was the y value that goes with +1? 0.2. What do I have the y value that goes with 2? 0.04. Is that what you guys said? Okay. Now, that's going to be really hard to graph, right? 0.04 is going to be really hard to graph. So, again, none of our y values are negative. So let's go ahead and create an x and a y axis. We're going to draw our x-axis pretty low because we don't have any negative y values, so we don't need to look at that. And then we're going to plot these points. So -1, 5. 0, 1. 1.2 and 2.4. So do your best to plot them. They're just going to be really small. And we should not actually touch the x-axis, so do your best not to touch the x-axis. And this would be finished. Does anyone have any points, or I'm sorry, any questions about example A? Okay, let's try example B. Is this growth or decay, Quentin? How do you know? Okay, we don't look at the y-intercept. Remember, we look at the b value, and my b value here is 4. And 4 is greater than 1, so this is growth. Patrick, what is the y-intercept? Don't tell him. Look at example A. Where do we get the y-intercept from? And look at example B. Yep, 3. So we put 0, 3. Then we're going to use our calculator. And when we use our calculator, anybody have an idea how we're supposed to enter this into our calculator?
3 parentheses 4.
Okay.
X
So you can either do 3 parentheses 4 or you can do 3 times 4. So if you do 3 times 4 raised to the x power. Or you can write it just like it is 3 parentheses 4 raised to the x power. And then we go to our table. So we could probably graph negative 2.18, negative 1.7503. We could probably graph those first 4 from negative 2 to 1. What? Is your x value on negative 2? Arrow up and down till you get to negative 2.
Yeah, and then I mean, point 0.
I'm looking for 4 points on every graph that you do. Whatever 4 points you want to, but I'm looking for 4 points. Now, it's going to be hard to do 112, so I'm just going to approximate it up there at the top of my graph. Please hold off on number or letter C for just a minute. Hold off on letter C. Obviously, your graph is not going to be perfect, okay, because you're missing some points. And it's really hard to graph 0.19. I'm just asking you to do the best you can. Okay, on letter C, what is this a growth or decay, Crystal?
Decay.
Are you sure? How do you know it's decay?
Well, it's a decimal.
Okay, but is a decimal, what do we have to check to see if it's growth?
Fraction.
No. What does growth mean? The b value is what?
Positive.
Is greater than 1. Is b greater than 1? What is our b value? Is 1.2, Crystal, greater than 1?
Yes.
Okay, so is this growth or decay?
Growth.
There we go. This is growth. Paula, what is our y-intercept?
0, -7.
There you go, 0, -7. So we know that this is a growth problem. But I'd like you to plot this in your calculator and look at what that graph looks like. Right, so we know what the growth curve should look like. But what happens when we put this in our calculator? Let's try it. Please make sure you use the -7 at the bottom. I mean the negative sign at the bottom. It's going down, 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 right? Do you guys see how that's going down? So in our mind, that looks like decay, right? So it's still growth, but it's a negative growth, which seems really odd. But it's a negative growth. So when your y-intercept is negative, it's going to look backwards. Okay, so that's why we don't always go with what the graph looks like. We go with what we know to be true in our equation. Okay, so we're still going to go to our table. And some of these look like they might be hard to graph. So if we arrow up, I might start maybe at like, I don't know, -5, -4, You can pick what points that you want to graph. Notice that when you get where x is 0, you have your y value is -7, right? So go ahead and pick whatever points that you would like to. I just need 4 points on your graph. I would always put the y-intercept on the graph. That one's kind of a gimme. Now this time when you draw your x-axis, you should probably draw it at the top, right? Because none of our x values are positive. I'm sorry, none of our y values are positive. So 1, 2, 3, 4, 5, 6, 7. 7, -1.9, -6, -2.3, -4.
Oh, you don't want to do consecutive points?
No. 0, 7, 1, 2, 3, 4, 5, 6. You don't have to do consecutive points. Yeah, as long as you know that this is kind of what the graph looks like. Please make sure it looks like a curve, not a line. Any questions about this? No?